Collaborative filtering. Process of collaborating filtering is used for recommendation engines. It is nothing but the process of recommending products to users based on the purchase history of those similar users. So similarity between users can be found using distance measures like cosine distance or Jacquard distance. So this is used by major tech companies like Netflix, Spotify, and YouTube, to recommend new videos, to recommend new movies, or to recommend new playlists or songs to users. And this is it's done by analyzing the history of users who seem to have similar interests. The next thing is, this collaborative filtering method is used by major tech companies mainly because it is known to help personalized invitations, or send personalized offers to users, which in turn will lead them to spending more time on the platform. So there are two broad categories of collaborative filtering, as we know it. The first one is user-user collaborative filtering, which in a broad sense is recommending products to users based on the preferences of similar users. The second one is an item-item collaborative filtering method, which is used for clustering items which are bought by similar users.
Hello everyone, I'm Chaitanya from Group 6. I'm here to talk about data cleaning. So, data cleaning is the process of detecting and correcting corrupt or inaccurate records from a record set, table, or a database, and it refers to an identifying incomplete and incorrect or inaccurate parts of the data and then replacing a modified or deleting the dirty or incorrect data. So it can be performed interactively with data running tools or a batch processing through scripting data and any other technologies as well. So while so different methods can be applied with each has its own trade-offs. Overall incorrect data is either removed, corrected, or imputed. So while normalization rescales the values into 0 to 1, the intention here is to transform the data so that it is normally distributed. And in most cases, we normalize the data if we're going to use statistical methods that rely on normalized distributed data. So when considering movie ratings, for instance, normalization, if we normalize movie ratings, we usually get negative numbers for low ratings and then positive numbers for high ratings. And then similarly, like if we use cosine similarity, like cosine distance will be the opposite for users who have opposite views on similar movies watched. And in the same ways, like the cosine distance will be small for the users who have similar ratings on a common movie. When it comes to the eliminating similarity, we can categorize data based on similarity of movies highly rated. For example, the similarity between movies a user rates highly to those with low ratings can be eliminated by rounding off. For instance, like all the ratings that are above 3 on a scale of 5 can be considered 1, and the ratings below 3 can be considered unrated. So that's it.
Hey guys, my name is Venkat Sai Kaushik, and in this slide we are going to see duality of filtering and collaborative filtering. So, collaborative filtering generally is performed as user-user collaborative filtering. We can also perform item-item collaborative filtering. So, we can say item-item collaborative filtering as a dual approach for the user-user collaborative filtering. They both are pretty similar. In the item-item collaborative filtering, we take a given item and take a similar set of items to the given item, and we try to look for a user which likes the given item who also likes the given set of similar items. So we do this in the traditional method. We take a utility matrix in which the rows are the items and the columns are the users, and we also find the similarity measures like the Jacquard or the cosine similarity, and then we proceed to find the entry for user and an item. So this is the duality of similarity. So in theory, they both are pretty similar. We can say that item-item collaborative filtering is collaborative filtering in the item point of view. So One may say that they both have similar performance in theory, but coming to the reality, the item-item collaborative filtering uh, will outperform the users of collaborative filtering. This is because items are easy to classify than the users. For instance, if we take a user and he likes two genres of music, say rock and classical music, then we can find a item rarely which belongs to two genres of the music, and so we can see that items are very easy to classify, but users are somewhat tough to classify. So next comes the clustering of users and items. We saw that we had a problem of classifying the uh, users in reality. So we can use clustering to overcome that problem. We also have the shortage of information for the item user pairs. So we can also use clustering to overcome this problem. So clustering is basically performed to minimize the information which we have. So clusters are basically formed either for items or users, or we can do it for both. Clustering is formed. Clusters are formed by taking distance metrics that we know, like the Jaccard or cosine or any other distance metrics. So initially we form clusters for a small number of items or users, and later we go on increase taking an hierarchical approach. So after forming of the clusters, what we'll do is we will take a utility matrix. We can say it as a cluster utility matrix, and later we fill up the utility matrix if a cluster of users and cluster of items have entry, and we leave the rest as blank if they do not have an entry. So we can use this utility matrix to find the relation between a user u and user I. So if we take a user u and a user I, then we can see they have whether the user can like the item I or not. Like we have to take the clusters to which you and I belong. Say they are A and B. We take the A and B clusters from the cluster utility matrix and take the entry of them, and then we can fill it up to the entry of U and I, so that we can know that how much you may like I. In if in some cases we do not have any relations between the clusters A and B, then we might have to go for the traditional collaborative filtering method.
Hello, this is Aishwarya. Today we are going to talk about dimensionality reduction. So, dimensionality reduction is simply the process of reducing the dimension of your feature set. Suppose your feature set could be a data set with hundreds of columns, and it could be an array of points that make up a larger sphere in three-dimensional space. Dimensionality reduction is what it does is it's bringing the number of columns down to say 10 and 20 and converting the sphere to a circle in a two-dimensional space. It is done by one of the techniques known as UV decomposition, which allows us to decompose a matrix M into the product of two matrices, say U and V, to estimate the blank values within the matrix M. So it is as shown in the below diagram. It is typically judged by the root mean square error.
Here's a question. Which method could be used to group users and items into categories to make recommendation easier? The answer is clustering.